So for this problem, we're looking at two objects which collide and then continue moving while sticking together. So we'll be using momentum to solve this problem since it's an inelastic collision. But before we do anything, let's first just draw out what's going on so we can visualize it and so that we can also see all the different values that we've been given. So first of all, we have our male ice skater, and we'll represent him with this box. And the problem says that he has a mass of 82 kilograms, and we'll refer to him as M1, mass 1. And the problem says that he's moving to the right, he's skating to the right, at 8 meters per second. So we'll refer to his velocity as V1. And then there's another ice skater, a woman, who's traveling to the left, so we'll draw her velocity like this. And her mass is 59 kilograms. We'll refer to her as M2, and her velocity is 10 meters per second, and we'll call that V2. Now, since we're working with velocity, which has both a magnitude and direction, it's really important to consider the direction of their travel. So if we're going to use a standard x coordinate graph axes, we're going to call this direction to the right positive and this direction to the left negative, which means that our male ice skater is going in the positive direction, but the female has a negative velocity. So now that we have all our values and we can visualize what's going on, we can start solving the problem. So like I said, all we need to do is a simple momentum comparison. If there were external factors or forces working on the system, then we would need to factor in some other things. But since they're on ice, which we're considering to be frictionless, all we need is the initial momentum and the final momentum. So we'll start by saying their initial momentum is equal to their final momentum, and then we can expand upon this. So we're going to say their initial momentum is M1 V1 plus M2 V2. So it's the woman and the man's personal momentum before colliding. And that's going to be equal to the final mass, and the final mass when they collide will be both of their masses combined. So M1 plus M2. And then what we're solving for is our final velocity. So we're going to call that VF. And then all we need to do is substitute our values. So we can see that M1 is 82 kilograms. V1 is 8 meters per second. And then we're going to add that to M2, 59 kilograms, times negative 10 meters per second. And that is going to be equal to M1 plus M2, so 82 kilograms plus 59 kilograms, which is equal to 141 kilograms. So we'll just write that as 141 kilograms times V final, which is a variable that we're solving for. So we have all of our variables plugged in. All we need to do is the algebra. So I'm going to skip that step and move straight on to the solution. So when you do the algebra here, you find that VF, our final velocity after the collision, is going to be equal to 0.468 meters per second. So basically a half meter per second. We can see that this value is positive, which means that together they're moving in the positive direction. But since this is obviously not a very fast velocity, it's not a very high value, their initial momentums were pretty similar, but our man's M1 initial velocity, momentum was a little bit higher, and that's why they continue in the positive direction after colliding.